All right, here we go. So we are starting with 1.2. This is part one. We're solving linear equations. So I can use inverse operations to solve linear equations. So key terms, we're going to start with equivalent equations. These are equations that have the same value for the values of the variable. So that means if I solve an equation and I get x equals 2, and I solve another equation and it's x equals 2, those two equations would then be considered equivalent because they came out as the same value. Inverse operations are operations that undo each other. Addition undoes subtraction and vice versa. Subtraction undoes addition. And then multiplication undoes division and vice versa. So when we solve equations, we need to remember that we need to isolate the variable. We isolate it by getting the variable alone or on one side of the equation, or in this, we're going to talk about inequalities later. And that's in order to actually solve the equation or inequality. We are not technically solving if that variable is not alone or isolated. So solution to an equation is the value or values that make the equation true. That's when we get x equals 5. 5 is the thing that if I plugged it in, it would make the statement and the equation correct. Okay, so another way to think true is correct. And then variable is that symbol used to represent the quantity that can change. It's normally x and y, but we can use all sorts of letters and actually symbols. So we have the same equation here on both sides, but we are going to show that we can solve equations in so many different ways. So for right now, we're just going to show at least have two ways. All right. So for me, so I'm going to do this first one very much for me. I can see that that fraction piece has a lot going on, and the 8 has really nothing connected with it. So I'm going to get rid of this 8. It's being subtracted, so then the inverse is to add it, right? So I'm always going to add or subtract or multiply or divide to both sides. Remember, that keeps it balanced. So I rewrite what I haven't done anything with. This all stays, and I'm going to get that equals 40. So the next thing I'm going to do is distribute. So remember, distribute is where I multiply the outside to everything on the inside. So 2 times x is 2x, and then 2 times 4 is 8, but I didn't do anything with this 3, so I'm going to leave that down here. So I really can't divide by 3, but the inverse of dividing is multiplying. So I can multiply both sides by 3. That gets rid of that division now. And I can do that. I almost can protect these with parentheses to do that as well. So now I have 2x plus 8 equals 120, right? 3 times 4 is 12, add that 0. Now I have a 2-step, right? So I'm going to get rid of that 8 first. I'm going to subtract 8. I'm going to get 2x equals, well, I got to borrow. That's 2, 1, and 1, 112. And then we're going to divide by 2. We're going to get x equals, oh, I forgot to divide by 2 there. So 2 into 11 is 5. 1 left over is 12, so 56. Okay, so what I'd like you to do is maybe pause and see if you can solve it differently, meaning you can't do every step that I did. Maybe you do the same at some point, but maybe you do it in a different order. I just want you to see if you can get to the same answer I did by solving it in a slightly different way. We'll go over that in class. All right, so here's more of a story problem or problem-solving type of problem. It says the sum of 3 consecutive integers is 132. what are the three integers? So we're going to first write an equation and then we're going to solve it. So the main things are we are looking for the sum, so that's adding. It says is 32, remember that's equal. What does, oh, there's three of them and they are consecutive. So remember consecutive is one right after the other. So 1, 2, 3 are consecutive, right? 10, 11, 12 are consecutive. So they're exactly in order. Now we don't know what any of them are, but what I do know is they're one right after the other. So let's say we start with our first number. Let's start with this way. Let's say my first number is 1. I know it's not. But my next number is the next one in order. That's 2. But 2 is the same as 1 plus 1. So now I have a consecutive set, 1 plus 2. Well, then I need a third number. That's the number 3. It has to be consecutive. Well, that's the same as 1 plus 1, plus 1. That says 1 plus 1 plus 1. So what I wrote at the top is exactly the same as what I wrote on the bottom. So that's what they're kind of looking for. What are those three numbers? Now, the reason I did that is because how we're going to write our equation is I don't know what the number is. I don't know what any of them are. So I don't know what the first number is. We're going to put X. We are going to add the second number. Well, I know the second number is the first number plus 1 because it's the very next number. And I know that the third number is X plus, and I'm going to write 2 because 1 plus 1 is 2. It's 2 away from my first one. And we know that's going to equal 132. So here's my first number. This is my second number. And this is my third number. But I had to use a variable because I don't know what any of those numbers are. But I can't use X plus Y plus Z. We don't know how to solve for that. So we use one variable. So remember, we want to combine like terms first. So if you see, I have, oh, I don't like that color. I have 1x, 2x, 3x, and then I have a constant and another constant. Remember doing this? So I have 3 x's, and I'm going to add 3 to them, because 1 plus 2 is 3, and that's going to get my value of 132. So now I can just solve this like a two-step equation. Adding 3 inverse is subtracting 3. I'm left with 3x, and that equals, so I have to borrow 12, 11, 10, 9. Nope, that should be 2. And then we're left with 129. Inverse of multiplying by 3 is dividing by 3. And so we get that x equals 43. Now that's just the first number. It says they want all 3. Well, if that's the first number, the second number is just one more, so 44. And the third number is just one more, 45. Now to see if we did okay, we would need to add these together, right, to make sure they actually equal 132. So 5 and 4 make 9. 9 plus 3 is 12. Well, there's my 2. And then 4 plus 4 is 8. Plus 4 is 12. Plus my 1, that's my little floating 1. So I, in fact, did get 132, so I'm okay. All right, so here's some more practice with some distributing and combining like terms. I'm going to start this one, and then I want you guys to pause, okay? So I'm going to distribute first, And we should get negative 15 equals 15, and that's a Q, minus, now we need to remember, this was a negative 10, and it's being multiplied by a positive 5, so it needs to stay negative, so 50. And then we leave this 5Q alone because it wasn't inside the parentheses. So now I want to combine my like terms. I have 15Q and negative 5Q, and then I have a constant, negative 50. So I'm going to get negative 15, no, didn't do anything for that, equals, well, if I have 15Q and I take away 5Q, we should get 10Q. And then we're going to minus our 50 because we didn't have anything else with it. So two-step equation, I'm going to add 50, add 50. These are opposite signs, so I need to really subtract. So 10 is 5, so 35 positive. And we're going to have 10Q over here. So this is where we're going to divide by 10. Now, I'm not going to make you guys find the decimal of that. We can just reduce it. So we'll reduce both of them by 5. Right? I'm not going to make you find the decimal. We're just going to reduce by 5. And so we would leave this as 7 over 2 equals Q. Okay, I don't like decimals. I don't want to have to find them, so I just like to reduce and leave my answer as fractions. All right, so pause here and try this one out. This one's a little trickier. I'm just going to give you a hint. That's a negative 2, but this is also a negative 2, so make sure you catch both of those. Okay, so hopefully you paused. So when we distribute here and here, we get 15 minus 6, but you should have gotten plus 4x is 46, because a negative times a negative is a positive. So when we combine our like terms, that's 15 and negative 6, and then the 4x is by itself. So 15 take away 6 gets me 9, and I'm going to have plus 4x. So you'll notice if you clean these up correctly, you'll pretty much always end up with a 2-step. And if you're really lucky, you'll end up with a 1-step. So notice I always deal with my constants first. I'm going to minus 9. We're going to get 4x equals 46 take away 9 is 30. I'm blinking. 7. Is that correct? I don't know. Right? All right, you guys can correct me in class. I'm spacing right now. And then we're going to divide by 4. And I'm going to just get x equals hopefully 37 over 4. All right. If not, you guys will correct me. All right, so here is your independent practice. So this first one is very similar to, actually it's identical to the one we did with the consecutive integers, but it just equals something else. And then this other one is pretty similar to that first example we did where we had to solve it 2 ways. You don't have to solve it 2 ways, just solve it 1 way, but it's very similar to that one. Okay, so first example, the bottom one's like the first example and the top one is like the second example. All right, until next time.